So for the new session, which again, we are in consumer theory. So today we may finish the consumer theory part from the 0 to 100. So the first topic that we will work on that is the duality and consumption. I mean the relationship between utility maximization and expenditure minimization problem. UMP, utility maximization problem. EMP is expenditure minimization problem. And while we are working in this duality and consumption, then we will have some important identities. And that important identities will help us a lot in consumer theory. So when we know those are important identities, it's easy to switch the way between utility maximization process and expenditure minimization process. And finally, we will have the third one, manometric utility function, which is direct and indirect. And we have comparative statistic. There is no, the aim is dropped. This comparative statistic, we have income expansion path and also price offer curve. And lastly, in terms of like consumer theory, we will have the Slutsky equation. So first of all, what is the duality and consumption? If you remember the last session, we already said that it doesn't matter that we start from the utility maximization or we start from the expenditure minimization. So we will have the similar solution. For example, if you want to find the optimal bundle of X1 and X2 from utility maximization process, it will give you exactly the same result if you find out this optimal bundle from expenditure minimization process. So if we are going to maximize our utility function such that the Px is less than and equal to our income. This is the condition, that we maximize our utility such that Px is less than and equal to income. So this P and X are the vector of prices and consumption bundle. So if we have two goods in our consumption bundle, so then this P can be P1 and P2, and X can be X1 and X2. If we have three, then it can be X1, X2, X3, P1, P2, P3. And also, if we are going to minimize our consumption, our budget or consumption, which is equal to our income, such that our utility function is equal to some utility level of U. Is equal to some utility level of U. So if we maximize our utility function, by maximizing our utility function, we will find out the Marshallian demand function. And that Marshallian demand function, X is some function of prices and income. X is some function of prices and income. And if we minimize this expenditure, then we will find out the Hicksian demand function, which is our X, H, demand of action, is equal to some function of prices and utility. Is equal to some function of prices and utility. And later on, if we plug the value of this Marshallian demand function into our utility function, we will get our indirect utility function. Our indirect utility function, which is our V, which is indirect utility function, is also some function of prices and income. And if we plug the value of action demand function into our consumption or into our budget constraint, so this is budget constraint, Px is equal to M. So if we plug the value of action demand function into budget constraint, we will move to our expenditure function. Expenditure function. which this E, which stands for expenditure, will be some function of prices and utility. Will be some function of prices and utility. So also, we can use the other way around. For example, if we have our indirect utility function, so we can find out the Marshallian demand function by using Roy's identity. By using Roy's identity. Do you remember the formula for Roy's identity? So if we have our indirect utility function, by using Roy's identity, we can find out the Marshallian demand function, which is x. It's not a good color at all. Let me use this one, which is our x as a function of P and M is equal to negative the partial derivative of indirect utility function with respect to the price. For example, if this is xi, this is pi, divided by the partial derivative of indirect utility function with respect to income. So if we have indirect utility by using Roy's identity, for example, if we find out the optimal bundle for xi, then xi as a function of P and M will be equal to minus partial derivative of this indirect utility function with respect to price of I divided by the partial derivative of indirect utility function with respect to M. Then we can find out the Marshallian demand function. And also, similarly, for the case of expenditure function, we can use the other way around to find out the action demand function. And the way that we move from expenditure function to action demand function is called the Shefford lemma. By using the Shefford lemma, we can find out the action demand function from the expenditure function. It's easy, because in the case of Shefford lemma, we don't need to take derivative 2 times. For then h of I, for example, the action demand for good of I is equal to the partial derivative of this expenditure function with respect to the price of I. When you take the partial derivative of expenditure function with respect to the price of I, you will find out the optimal level of action demand function for that I. Action demand function for that I. So this is this way and this is this way. But the question is, where is then the duality? So it's this way, it's this way. The duality comes from here. So if we have our indirect utility function, we can find out our expenditure function. We can find out our expenditure function. Or, for example, we have our indirect utility function, which is VPM. Yeah? VPM is equal to some utility level of U. This utility level of U comes from this one, action demand function. When we add this action demand function to our utility, what we have is some optimal utility level. So again, when we plug the value of our optimal consumption level to the utility function, we will find out the optimal utility level, which is U, or sometimes U star. Sometimes U star. So we only know that, we also know that M, this M, can be written as a function of P and U, which is our expenditure function. So instead of M, we can write VP EPU. is equal to u. VPU is equal to u. So it means then isolate the EPU from this function so we can find out our expenditure function. So when we have indirect utility function, we can find out our expenditure function by substituting the EPU instead of M. Using EPU instead of M. And another way around, if we have our expenditure function, we can find out our indirect utility function. So in here, our expenditure, which is a function of P and U, is equal to our income level. Then instead of this U, we know that this U is equal to VPM. Then E, P, instead of U, write down VPM. And is equal to M. So in this case, we isolate EPU to find out the expenditure function. For this case, isolate VPM in order to find out the indirect utility function. And also, we have another duality between the Hicksian demon function and the Marshallian demon function here. We have a duality. You see that the Marshallian demon function is equal to x as a function of P and M. X is some function of P and M. But here, we have some function of P and U. So let me check that for So let me clean this part. Let me write down again. So if we have our Hicksian demon function, which is equal to XH PU. And here we know that the U is equal to VPM. Then XHP, and instead of U, write down VPM. So now, this demon function is a function of price and income. This demon function is function of price and utility. And we know that if our demon function is a function of prices and income, so it is our Marshallian demon function. So then this one is equal to some function of P and M. I mean, when we have our Hicksian demon function, instead of this U that we have here, just plug the value of our VPM. Then we have this function, x as a function of P and M. So x as a function of P and M is where? Here. And it's called Marshallian demon function. So from Hicksian demon function, we found out the Marshallian demon function. Similar, another way around, if we have our Marshallian demon function, we can find out the Hicksian demon function. How we can find out the Hicksian demon function then? So we have our Hicksian demon function as a function of P and M. And we know that this M is equal to EPU. So instead of M, write this one, x as a function of P, EPU. So then this function is a function of only P and U. If our demon function is a function of price and utility, it's what? It's our Hicksian demon function. Then this is XH. So this is the duality. So if we have Marshallian demand function, we can find out action demand function. If we have action demand function, we can find out Marshallian demand function. If we have indirect utility function, we can find out expenditure function. If we have expenditure function, we can find out the indirect utility function. And if we have the indirect utility function, we can find out by using Roy's identity Marshallian demand function. If we have expenditure function and other way around, we can use the Shefford lemma to find out the Hessian demand function. So it's a kind of summary of all the consumer theory that we have. So that's why we say that there is a duality exists between the utility maximization problem and expenditure minimization problem. So this is the utility maximization problem. And this is expenditure minimization problem. Any question? Yes, sure. If we have this utility function, which is x1 to the power of alpha, x2 to the power of 1 over alpha. So as you know already, this is a Cobb-Douglas utility function. And we can use Lagrangian method. Which has like 3-step. Marginal rate of substitution is equal to economic rate of substitution. mu1 divided by mu2 is equal to p1 divided by p2. And the second step are p1 x1 plus p2 x2 is equal to m. So when we use this process, our x1 star will be equal to alpha m divided by p1, and x2 star will be equal to 1 minus alpha multiplied by m divided by p2. So this is the optimal bundle for the x1 and x2. So the first step from utility maximization process. If we maximize our utility, so we will find out the value of x1 and x2. This one and x2 is a function of m and p. So this is called Marshallian demand function. This is called Marshallian demand function. And if we plug the value of this Marshallian demand function into the utility function, what we will get is indirect utility function, which is v. Then our v as a function of p and m will be equal to, and instead of x1, write down the value, alpha m divided by p1 to the power of alpha multiplied by 1 minus alpha m divided by p2 over to the 1 minus alpha. So this is our indirect utility function. So we can further simplify. So then the final result will be equal to m divided by alpha over p1 to the power of alpha multiplied by 1 minus alpha divided by p2 to the power of 1 minus alpha. So the utility maximization process is done. We did the first step to find out the Marshallian demand function. And we did the second. This is the first. This is the first part. We did the first part, find out the Marshallian demand function. And we moved to the second part to find out the indirect utility function. Find out this indirect utility function. So now we can move on to our duality. So how we can move on to our duality? First, we have M, we have P1, we have P2, and we have VPN. As we already said here, that our VPM is equal to U, and our EPU is equal to M. So now, here, instead of M, write down EPU. And instead of VPM, write down just simply U. from here. You know, VPM is equal to U, and EPU is equal to M. So here, instead of VPM, write down U, and instead of M, write down EPU. So then it will be equal to U is equal to EPU multiplied by alpha to the P1 to the power of alpha multiplied by 1 minus alpha divided by P2 to the power of 1 minus alpha. So then isolate this EPU. So how we can do that? You can write down EPU and divide both sides to this term. And we will move to U divided by alpha P1 to the power of alpha multiplied by 1 minus alpha P2 to the power of 1 minus alpha. You see, this is a function of U as a function of P1 and P2. This is EPU. So by having the indirect utility function, we found the expenditure function. And also, as we have, if we have the other way around, if someone gives you this one, that this is your expenditure function, give me your indirect utility function, then what we do, and instead of this U, write down VPM. And instead of this EPU, write down M. And then we can find out VPM by M. The first one, that VPM. How we can find out VPM? If we use the utility maximization process and maximize our utility, maximize our UX, then we will move to some U star, which this U star is our optimal level of utility or maximum level of utility that we found out from utility maximization. So the first identity, VPM is equal to U star. Just forget about this part. VPM is equal to U star. And sometimes we just simply write down U. Even don't think about U star. And the second identity is that EPU, how we can find out the expenditure function? We can find out the expenditure function by minimizing P multiplied by X. I mean, what we consume for buying X. Then it's equal to our income level. So expenditure function is equal to income level. So by having that income, we want to minimize our expenditure in order to, like, another way to maximize our utility. The third one that we can find out from that duality condition is that VPM is equal to VP, and instead of M, we can write down EPU. EPU. You can write down EPU. Then, this one, as we already know that the VPM is equal to this U. VPM is equal to this U. The fourth one, we know that EPU and also this U can be equal to VPM. Then we can write down VPM is equal to M. Is equal to M. The fifth one, if we have our action demand function, which is a function of P and U, our action demand function, which is a function of P and U, and then XIH P, and instead of U, we can write down VPM. VPM. And now, before our function was a function of P and U, and now our function is a function of P and M. Then we can write down X as a function of P and M. XI. This is the Hickson demand function. This is the Marshallian demand function. By plugging the value of indirect utility function into Hickson demand function, we can find out the Marshallian demand function. The sixth one, if we have our Marshallian demand function is a function of P and M, and we know that M is equal to EPU. Then write down EPU. Then this function is a function of P and U. And then our demand is a function of P and U. It's called Hickson demand function. It's called Hickson demand function. There is 6 identities that we can draw from this duality. So there is one other duality as well. Another duality which exists between indirect utility function and Hickson demand function, and between expenditure function and Marshallian demand function. Why? As we said already, if instead of U in the Hickson demand function we substitute indirect utility function, we get Hickson demand function. So it means here, if we substitute indirect utility to the Hickson, we will get the Marshallian. If we substitute indirect utility function to the Hickson, we will get the Marshallian. Another way, if we substitute the expenditure function here instead of M, write EPU, then we will get the Hickson demand function. So there is duality between indirect utility function and Hickson, expenditure, and Marshallian.